Hi, in this video we solve question number 17 of IIT JAM 2021 mathematics paper. Here's the question. F is a real valued function which is infinitely differentiable such that for every real number a less than b, you have f of b minus f of a divided by b minus a is equal to f prime a plus b by 2. There are 4 options to this question and only one of them is the correct one. Let's go through them one by one. The first option is that f must be a polynomial of degree less than or equal to 2. The second option is f must be a polynomial of degree greater than 2. You see, option B is like a complementary statement to the first one. Then you have option C, f is not even a polynomial. Then you have option D, f must be a linear polynomial. Now, if you observe these options closely, you will realize that these options are very complementary to each other. Meaning, if you were to find a simple example that satisfies the given condition, then you will be able to eliminate some of the wrong options. And that is what we are going to do in this problem. And in fact, with experience, you will realize that whenever you have such problems where you have a function satisfying some given condition and you have to say something about the properties of the function, going for an easy example is a quick way of finding the correct answer. Well, let's get started with the solution and let's see if we are able to find the correct answer very quickly. Here is an easy example we can consider. Let us consider the function f of x equal to 1 for all x. This is a constant function which is also a constant polynomial. So it is a polynomial of degree 0 in fact. And we can see that it trivially satisfies the given condition. Both the sides of the condition are 0 in this case. Now let us cross-examine our options against the given example. Option A doesn't contradict the given example because our example is also a polynomial of degree less than or equal to 2. So we can't say anything about A, but it certainly eliminates B because our example is not a polynomial of degree greater than 2. C is also eliminated because f is indeed a polynomial in our example. So we have C not in the answer. What about D? D says that f must be a linear polynomial, but in our example it is not a linear polynomial, so D is also eliminated. So what's left is that option A. So option A must be the correct answer. Now, as usual, we will dive deep into the mathematics behind the correct answer and we will actually prove that A is indeed the correct option. Now to prove that, what is it we want to prove? We want to prove that f must be a polynomial of degree less than or equal to 2. In terms of derivatives, it suffices to prove that the second order derivative of the function is a constant. Very well, let us recall the given condition first. We have f of b minus f of a equal to b minus a times f prime a plus b by 2. We will now manipulate this condition to prove that f double prime is indeed a constant. Now one thing to notice here is that interchanging a and b in the above condition doesn't really matter. You can interchange the positions of a and b and it doesn't really matter because if you multiply both sides by -1, what you get is a and b flipped and both the conditions are exactly the same. So it says that we can actually play around with any two numbers and we wouldn't have to worry about their orders. So here is a trick. What you do is choose a equals to x plus y. Choose b equals to x minus y. This implies that their average a plus b by 2 is simply x. So we lose one variable in the average. Now with these values of a and b, we get the following equation from the given condition. F of x plus y minus f of x minus y is equal to the difference of a and b in this case is 2y times f prime, the average of a and b is x. Now what we do is, because we want f double derivative in the picture, we differentiate both sides, but we differentiate with respect to y. So derivative of the first term with respect to y minus derivative of the second term with respect to y is equal to 2 times the derivative of y with respect to y, because f prime x only depends on x. It is a constant in this case. So now what we do is apply the chain rule of derivative. We get f prime x plus y times derivative of x plus y with respect to y minus f prime x minus y times d by dy of x minus y. This is equal to derivative of y with respect to y is 1, so we get 2 times f prime x. Now simplify further. We have f prime x plus y. This minus becomes plus. F prime x minus y is equal to 2 times f prime x. Now the right hand side is independent of y. Now we are going to differentiate both sides with respect to y once more, and we get the following. Using the chain rule as earlier, we get f double prime x plus y plus becomes minus, then you have f double prime x minus y is equal to 0. Very good. Now this gives the following. F double prime x plus y is equal to f double prime x minus y. This happens for all x not equal to y, but because of continuity, this happens for all xy. Now, this is very good. What we do now, because we have to show that f double prime is a constant, take x equal to y, and we get the following. F double prime 2y is equal to f double prime 0. This happens for all y. Because this happens for all y, replacing y by 2, you can conclude that f double prime y is actually equal to f double prime 0 for all y. This means that f double prime y is a constant independent of y, and this proves the answer.